So first derivative test says you check if the derivative changes sign from negative to positive at the critical point, then you have a min. If the first derivative changes sign from positive to negative at the critical point, you have a max. But you have to check three things then. You have to check left, right, and on. For a second derivative test, you only have to check two things. One, set the derivative equal to 0. Find the critical point. Take that x value, stick it into the second derivative, and just check the sign on the second derivative. And you can determine from that if it's a min or a max. Does that make sense, guys? Pretty useful test. Alright? So a lot of good stuff. So then, okay, let's do our little hand stuff here. Yeah?
I'm just having trouble picturing like the inflection points. Are they like the point at which the slope like changes from positive to negative?
Yes. There we are. Let me sketch this in, and we'll see one here, and then we'll get to one where you can actually, yeah, exactly. It's going to be literally like a snake. It's always the snake point. It goes from concave up to down. And it's like a kind of a weird point that's somewhere in there. Does that make sense? Mm-hmm. And we'll take a look at this graph. First, let's make our hands. Decreasing concave up. What does that look like? Show me your hands. Decreasing concave up. Increasing concave up. Increasing concave up. I don't see any hands. Increasing concave down. Increasing concave down. So do your hand and check it. Do you know what I'm saying, Jesus? Do it and do it. Decreasing concave down. Okay? Which means this function is going to do this. So if I put my little spacings here. And again, I don't know where high and low. I only know overall this function is going to go decreasing, increasing, and then check this out. I mean, right here, it's going to keep on increasing, only do that, and then come down. Do you see what that little squiggle? In this section, it's going to be increasing concave up, but then over here, it's increasing concave down. So in this area, it's going to be that, like, kind of this action. Does that make sense? If we take a look at this graph again, that's what's happening. Now, you can't calculate, there's no second calculated inflection point on your calculator, like there is a min or a max. You know what I'm saying? Right at 1. It goes from that min, so it's still concave up, and then somewhere between 0 and 2, which we calculated was 1, it changes, because then it becomes a max, and you see it like then it goes concave down. Do you see that, you guys? So again, something that you can't solve for on the calculator. The only way you can solve for them is find that second derivative. Again, you can guess. You know, that's roughly there, but you can always set the second derivative equal to 0 to solve for that inflection point. Okay? Now, another interesting one, again, if you get something like x to the 4, y equals x to the 4, first derivative equals 4x cubed. Critical point where? Yeah, add x equals 0. Take the second derivative. I get 12x squared. Critical point at x equals 0. Or possible inflection point. So if I sketch this out, all my actions happening at 0. First derivative. Second derivative in function. First derivative equals 0 at 0, and second derivative also equals 0 at 0. So now let's check the signs on increasing and decreasing. Let's check the sign on the first derivative. Well, here's my first derivative function. If I plug in a number to the left of 0, like -1, is this going to be positive or negative? Negative. What about to the right? Positive. Second derivative. Okay, here's a possible inflection point. To the left? To the right? What the heck does that mean? Is this an inflection point? No, there's not a change of inflection. It equals 0 though, but it stays positive to positive. What this looks like with our hands, again, is decreasing concave up to increasing concave up. It just looks like an x squared graph. But weird things are happening just because it's this x to the 4. Okay? So again, not all second derivatives equal to 0 are inflection points. You have to check to the left and to the right. Just like not all critical points are mins and maxes. You have to see the change in sign in a derivative in order to have a min or a max. You have to have the change in sign in second derivative to have an inflection point. Okay, it's things to check. Does that make sense, you guys? Yeah? Okay, we have time for one more. Sneak another one in. Okay, I'm going to erase all that stuff on it. But this graph right here in 41 is a position versus time graph. And I want to know when is the velocity 0 and when is the acceleration 0. This graph right here. Just talk about it in your groups. You don't have to draw it or anything. How do you know? Let's see if I can. It's a little blurry. When's the velocity equal to 0? And when's the acceleration equal to 0? Just talk about it in your groups. When's the velocity equal 0? Where? If this is a position graph. At the mins and maxes. Here, 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 and maybe there. Well, acceleration is the second derivative. Where's the acceleration going to equal 0? At the inflection point. So where do we see those? I don't know, here-ish. Somewhere around here. Kind of gave up here.